Let me introduce Gunther Schauberger, who has already been speaker on this occasion. Gunther Schauberger is a professor in the Department of Biomedical Science, the University of Veterinary Science of Austria, Vienna. His expertise consists on environmental impact assessment and environmental science related to animal production. So, Gunther, for you.
Thank you very much. I think it's not a very good job to be the first after lunch, so I hope there's a bit blood left for the brain and not all for the tummy. So it's a great pleasure for me to present this ongoing project. I mention here Jennifer Barclay. She helped me to present the presentation, and of course Carlos Diaz. I will mention him a bit later. But there are so many colleagues here that they are which are part of this group. So Jean-Michel and Claude. So Laura. So I'm really only primus inter pares in this context, and I want to present you our ideas and the background why we want to write a handbook on odor assessment. It's a handbook and not a guideline, so we are neutral against different tools, and we will bring together the idea and the advantages and disadvantages of different tools. So I want to give you a short overview. It should present guidelines all over the world, and it should give an overview of the state of the art, which tools are in use, and we follow the source pathway receptor, starting with the emission up to the decision if annoyance can be expected or not, and it should be used for an effective odor management. In this way, we organize this handbook. It should give a benefit to all countries, even if they have no active odor regulations. There is a big issue, ambiguous odor terms. There are a lot of different terms which are used, and sometimes it means the same, sometimes it's a bit different. And we want to present this in an overview. There are about 50 experts in this field. 17 countries are involved, and we have once a month a plenary meeting, and this is one of the success of this handbook, that we have a regular meeting in this way. Why environmental odor? I think it's on one side, in the EU, odor is not mentioned as an ambient pollution. On the other side is the most important environmental issue for wastewater treatment plants and for biosolid management facilities. And after noise, it's the most number of complaints caused by environmental odor. We have the problem of odor emissions on one side and inhabitants on the other side. We have heard this for Chile, for example, the problem of not a good territorial management, that we have decreasing distance between odor sources and the inhabitants with a lot of problems. And we have an increasingly higher environmental expectation of people living even in areas where they should expect odor. So these are the reasons why environmental odor is a big issue more or less all over the world. We follow this source pathway receptor. We start with a group defining the terms and units, discussing which definitions are included here. Odor emission is a big task. We have heard from Tom that, for example, emission methods are not included in standardization because there are too many uncertainties in this field. So there is a lot of open questions. We have a big problem with metrology, how we define metrology, which data are needed for the metrological citation. Part of the metrology are dispersion models, how we describe the dilution in the atmosphere, and dose response relationship is a big issue, how to convert the odor exposure to annoyance. And for consultancy, what should be included in reporting? What's absolutely necessary to include in a report which judges an odor exposure? As I had said, the organization of the plenary meetings, this is done by Carlos, and the organization by technical groups, and each group has a leader, one or two leaders, and they organize the activities in these groups. The performance of this working group is based on Carlos Diaz. He is the gray eminence of the organization. He forced us to come together every month. Tomorrow we have the next meeting. So he is doing really a good job, and he is offering this platform where we share the documents, and I think this is one of the reasons why we are still together, and it's working quite good. For some in the world, it's not so convenient. We are on 1 month it's in the early morning for Europe, and in Australia at night, and the other way around the next month. So sometimes China and the US fall in between, and so then it's a bit hard to contribute if it's in the middle of the night. But this was a good way to include all members in the world. So some words defining the work, definitions, terms, units. We have a lot of discrepancies how to use, for example, odor concentration. The American way with a dilution threshold, which is a dimensionless unit, which makes it quite complicated to explain a dimensionless unit for a dispersion model. It's not easy to argue in this way. Or Australia with odor unit, which means a concentration, but without defining the volume. which makes it also a bit difficult to use it as a concentration of the phenol factors, which are used to make the step from the exposure to the annoyance. Metrology, there are several open questions. The question is a 1D metrology or 3D metrology better? The problem, if you are using a single met station, 10 meter high, wind measurement, is it representative for a certain site or not? Or should we use wind field models, 3D approach, or numerical weather prediction systems, which take into account the total flow around the site. We have complex meteorological conditions, land, sea, wind, upslope, downslope. We have valley winds. So there's a lot of problems. Length of the data set. Do we need all the time 1 year, or can we reduce for example, the measurement at a certain site to half a year, and which period is representative for this site? A big issue, stability of the atmosphere, how we categorize this, or have we to measure it by ultrasonic anemometers. Regular models is part of the next technical group. Emission, we heard a lot of this. Area source, point source, fugitive sources. The problem of sampling is an open question. Scaling, for example, odor emission factors. Ralf Both was talking about this. They want to improve the odor emission factor, and the activity value is, in Germany, the livestock units is the live mass of the animals. But the odor emission factor is a key issue. And for fugitive odor sources, we know that we have environmental predictors, wind velocity, temperature, and we also have time patterns, for example, time of the day, working hours, and work day and weekend difference. So emission is there are a lot of open questions, and the last point I want to emphasize is it really a good thinking? We are on one side, we are calculating the dispersion model on an hourly basis. On the other side, we are using a single value for the entire year. Dispersion algorithm, I don't want to go in detail. There are so many models used for this. One of the questions is we have a concentration distribution for a certain site, and all the dispersion models are calibrated by the mean value. And when you say it's a good calibrated model, it means the mean value has a good prediction. But for odor, we are interested in the tails, and everybody knows about statistics, knows that the tails are a big discussion. If you have fat tails or not fat tails, you can do a lot of very high sophisticated methodology, applied methodology to describe these tails, and we are only interested in these tails, and we don't know how good are dispersion models calibrated for these tails. Because in this tail, more or less, these are they contribute only stable weather situation, not only, but a lot of stable situations. So, for example, the German impact criteria with 85 or 90% exceeding probability, it's a bit closer to the mean, but if you are using 98, 99 or 99.5 percentiles, then you have really low number of meteorological situations which contribute to this odor perception. Dose response, also a big issue. We are starting with the odor concentration, this hourly mean values, and we have several points which have to be considered. This is the peak to mean factor. We have heard about this. The hedonic tone, for example, using this hedonic profile to distinguish between stench and a nice odor. And on the other, we have the temperature and day time weighting. We have seen that many annoyance or many complaints are related to the annual. They have an annual variation. During summertime, you have much more, and you have, especially in the evening hours, you have a lot of complaints. So it could be the impact how much you are outside or inside a building, which is influencing the perception, and if you feel annoyed, and where you are living, and if you have any relation to the odor. Here you have such an example for such a dose response curve. The exposure is on the x-axis. On the y-axis you have the annoyance measure. Also, Ralph Both showed this for cattle odor and for pig and poultry odor. That it's a big difference in this dose response relationship. Yeah. Reporting, this should include all what's necessary to get a result for a certain evaluation of a source. I think this is more or less relevant for consultancy, and I want to come to the end. I think really the infrastructure of Carlos he offered for us is really a big help for us, and I think it's a quite challenge to coordinate members from academia, from consultant companies, and from administration. The point of view is totally different where you are coming from and what's your goal. By this, I think, positive resume, I want to finish. I want to thank you and all the members who are here. I want to thank that I was able to present our work in the name of all the members which are here. Thank you very much, and have a nice further talk. Thank you.
Thank you, Gunther. You showed us a lot of questions and one certainty, that's Carlos. Maybe one question for Gunther. Is there anyone? Yes.
Thank you, Gunther, for this very interesting presentation. And my question is if in this handbook you have also discussed the different approaches that can be used to estimate the peak-to-mean values. I mean, for instance, a constant peak-to-mean or peak-to-mean variable with the stability class and so on. Thank you.
Yes, I think there are several approaches now available. Some has to be used to, for example, the German one, this constant factor 4 has to be used to get reliable fit to grid data. This is a very nice combination of modeling and measurement in the field. Then you have to use this, for example, this peak-to-mean fact, this constant one. For other purpose, you can choose other approaches as well.
Are there other questions? No, then thank you again very much, Gunther, for your presentation.